We've got a curve with the following equation. We're asked to show dy by dx is equal to this. The big idea here, you should immediately spot, because x is equal to x is the subject of the formula, you're going to use the dy by dx is equal to 1 over dx by dy rule. Okay, so we're going to have to work out dx by dy and then do 1 over it. So we have x is equal to y multiplied by the square root of 1 subtract 2y. So x is clearly y, and multiplied by 1 subtract 2y to the half. So we're going to differentiate with respect to y. Tell the examiner what you're doing. Differentiate with respect to y. Usually you differentiate respect to x, not in this case. So you've got a product here, that's your u, that's your v, state it. U is equal to y, so u dashed is equal to 1. Your v is equal to 1 subtract 2y to the half. So your v dashed, bring down the half, differentiate the bracket, keep the bracket, but to 1 less power. So this would simplify to, that would be negative 1 subtract 2y to the negative a half. So we're going to use the product rule here. So state your product rule. So you're going to say your dx by dy in this case is going to equal uv dashed plus vu dashed, which are these two things multiplied together. So that's going to be negative y 1 subtract 2y to the negative a half, and with these two things multiplied together, so that's going to be plus 1 subtract 2y to the half. Okay, now we're asked to show that the following is true, so we better do some simplification here. So firstly, I would factorize out the 1 subtract 2y to the negative a half. Okay, and what would I be left with here? Well, I'd be left with a negative y. And what would I be left with here? Well, I'd be left with 1 subtract 2y to the half divided by 1 subtract 2y to the negative a half. Divide by means I subtract the powers, so subtracting a negative is like adding. I'd be left with 1 subtract 2y. So I'd be left with 1 subtract 2y to the negative a half, and this here would end up coming out to 1 subtract 3y. So I have the answer 1 subtract 3y divided by the square root of 1 subtract 2y. That's my dx by dy. And my dy by dx is 1 over this. So dy by dx is therefore the reciprocal of this, which is 1 subtract 2y divided by 1 subtract 3y. So I can look up here and see if I got it right. The square root of 1 subtract 2y over 1 subtract 3y, I've got it exactly right. Then it goes on to say the following. The point A on the curve has y coordinate negative 1. Show that the equation of the tangent can be written in that form where p and q are integers. So y is equal to negative 1. We want the equation of the tangent, so we want it in the form y subtract y1 is mx subtract x1, where we're going to need to have a pair of coordinates, y1 and x1, and we're going to need to have the gradient of the tangent to the curve at that point. So we are told that y is equal to negative 1. So let's find the x that matches that. If we know y is equal to negative 1, x would be equal to the following. X would be equal to, well, we know it's y square root of 1 subtract 2y, so it's going to be x is equal to negative 1, the square root of 1, these two multiplied will be 2, so the square root of 3, so it's going to be just negative the square root of 3. So our coordinates are negative root 3, negative 1. Okay, now we need the gradient. Well, we have got dy by dx from the previous part, so dy by dx, when in this case, because we have it in terms of y, we're going to substitute the y value in here to work out what it is. So dy by dx when y is equal to negative 1 is going to equal to the answer when I substitute negative 1 in there, which would be root 3 over 4. So I'm ready to state my equation. So y subtract negative 1 is root 3 over 4 x subtract negative root 3. So multiply everything by 4. I get 4y add 4 is equal to root 3x add 3. because this would be a plus, and root 3 times root 3 would be 3. And it's asked to give it in that form, root 3x plus py plus q is 0. So therefore, subtracting 4y off both sides, I get root 3x, subtract 4y, subtract 1. So in this case, p and q are integers. P is -4 and q is -1.